Okay, great. Looks like the majority of you have answered. Go ahead and close that out. Looks like the majority of you are using the device and an X-Rite device, so that is great to see. And with that, I will hand it over to Thomas to begin the presentation.
Hello, everyone. Thanks, Stephanie, for getting us started. Thanks for attending today's webinar. Again, my name is Thomas Meeker, 3D Solution Architect for X-Rite. I work with all of our appearance products, and today we're going to be specifically talking about automotive car paint and our ability to scan and represent these digitally. So with that, I'm going to get started. All right. So at X-Rite, we are the market leader in color communication, measurement, and formulation. And over the past few years, we've recognized that color is only one aspect about a material that needs communication and measuring. And so our goal is now moved from pure color to total material appearance communication. So our mission with this technology is to help folks with designers and marketing people and anybody in the product chain to use our new universal file format called the AXF, or Appearance Exchange format, to help in communicating all the material characteristics such as color and appearance data, including metadata, so other information about the material, and what we like to refer to as a digital twin. So the AXF allows for the creation of highly accurate digital material databases. So it allows us to create photorealistic and achievable design prototypes before we ever work with anything physically. And it also enables digital validation and control of materials for virtual prototypes along the supply chain. So this helps in, faster approvals and reducing prototyping and shipping costs. So an introduction to our total appearance capture system. First of all, what is appearance? So appearance is more than just color, like I said before. It's things like texture. Is there translucency, maybe transparency, gloss, and especially things in automotive paints like special effect pigments, so color flop or travel, and as well as like flake and special effect pigments like that. So what does it take to perceive appearance? First of all, there needs to be an object. So in digital world, we call it geometry, also the material, then microsurface. We also need lighting, so the scene and illumination. The context is going to make a difference. So in this image, we see things reflected in the car paint. And then also, obviously, an observer, somebody actually looking at these materials. So how did folks digitize materials in the past? Well, it originally began with artists using their skills to fake a material the best that they could. And so obviously this leads to a lot of subjective self-interpretation. And so as we move closer to wanting true physically correct materials, the next step was to use things like a texture scanner. So whether that was a flatbed scanner or just a camera setup. But now we have our total appearance capture system, which is doing full appearance measurement, making them physically correct, giving you the confidence to use these materials in digital production and for visualization. So just a quick test, if anybody, or if you guys just wanted to look at this and decide which one is the virtual and which one is the photo. I'll just give you a second. All right, we'll see if you guessed right. So the one on the left is the digital one. So one of the important things for us, and we use this method to help validate using camera and our SPLQC light booth, and then we recreate that virtually or digitally, in this case using the software Maya with V-Ray as the rendering engine to do a comparison. So very important, of course, that we're replicating the real world, the physical world, but also important that we have consistency across the different rendering platforms. So in this case, we have a V-Ray with Maya again, and then another software called VRED, which is primarily used in the automotive industry. So to take a look, when we first started this about 4 years ago, with the introduction of our TAC7 scanner, which I'll talk about more in a second, we had 3 partners that we could visualize our file format AXF with, and you can see that it's grown a great deal in the past 4 years. So we're very excited about our partners and their adoption of our file format. So here are some renderings that were done in 3D X-Rite DeltaGen, so Dassault Systems software. These were done for us by the folks over at Dassault. So just to take a look at a few. And you can see how these can really be used and to help sell the ideas from a designer's perspective or help in marketing materials as well. So just a quick summary of the benefits. So what are we trying to do here with our total appearance capture? Well, we're trying to accurately measure the color. Obviously, that's number one. So low delta E. We're also defining color through spectral information as opposed to just a camera RGB. That is something that puts us aside from our competitors in this world, and really gives us the advantage to true matching the physical world. We also have measured gloss, so it's not just made up numbers. So typically an artist would just be using a slider to try and get the correct gloss. We are doing true measurement. It works also for complex materials like translucent plastic, shiny materials or coatings. We capture complex appearance effects like anisotropy. Does it change depending on the viewing or lighting angle, and also the index of refraction for full material fidelity. AXF is a widely accepted data format across multiple industries and works with many tools, like we just looked at with that slide before. And X-Rite Pantone stands for more than 50 years of color expertise with a global service network. These devices are now available worldwide. We started off in the North American and European markets, and now we also offer them in Asia. So how are we doing this? What is the TAC technology that we're using? The ecosystem, as we refer to it, the total appearance capture ecosystem, contains 4 elements. The first one is the TAC7 material scanner. So that is what we are using to actually measure the materials. The second piece is the PANTORA software. The PANTORA software allows us to view and edit our materials, and by edit we just mean make the material a seamless material so that you can measure a small piece but actually use this across a larger piece of geometry. And then the virtual light booth. So this is our customers were asking for the ability to validate their materials in a more objective way, as opposed to holding the material up to their screen, which of course has its issues, being different lighting conditions. So we created the virtual light booth to help in validating those materials, as well as displaying the materials correctly for approvals and things like that. And then the last piece is the AXF file format. So I'm going to go into each one of these in more detail. So the TAC7 scanner, we are able to do the measurements in, it takes anywhere from 15 to 100, an hour and 20 minutes. This is a slide that still needs to be updated. But And then the measurement data size, this is the raw data that's created, can be anywhere from 20 to 120 gigabytes. Well, that is quite large, and a lot of the secret sauce in here is taking that data and creating what you see there at the end, which is a final AXF file of 1 to 200 megabytes. Inside of the scanner, we have a number of different technologies to help to do these measurements, such as a structured light projector is doing the texture measurement. The industry grade cameras are doing all the images that are then used to fit to the final AXF material. Spectrophotometer and variable linear light scanner, which the light scanner helps in actually measuring things like the color travel. 32 white LED point light sources, so those are turning on and off to show how light interacts with the material at different angles. Backlight module, that's used to do anything with transparency. Rotation stage to get the different views from different angles, and the 8 spectral light filter wheels. So those are what are used to actually do the spectral color measurement, similar to our spectrophotometers. So the PANTORA software, it has a number of features, one of which is an asset manager. So it allows you to actually create your own digital library and organize it in a way that's searchable and that you can view it quickly just right inside of our software. We also have our editor, which allows for tiling. I called it making seamless materials. It's the same thing, so that you can use those across whether it's small or larger geometries. You can also export the materials for different purposes, and some functionality for recoloring. The viewer, so that's what you see on the left, that is an OpenGL renderer, so that you can even look at a rendered version of that material right inside of our software. And then it's also the software that is the control for our TAC7 scanner, as well as the virtual light booth. So to speak a little bit more about our light booth, so it's using 2 different lighting conditions to be able to represent different types of materials. D65 diffuse, or that's our daylight 6500 Kelvin color temperature diffuse, or the D65 LED spotlight, which is great for high reflective materials and being able to see where highlights are, or that color travel. The spotlight is a much better lighting condition for viewing things like that. We also have position depending closed loop real-time color management engine. So we are actually calibrating the screens as well as the lights real time, so that you can make sure that you're always looking at it in a consistent lighting condition. And then utilizing our OpenGL real-time rendering engine as well. So in this image, you see this Converse shoe. The one on the left is a virtual, so that's actually a high brightness screen in the back that is rendering the image, and then the one on the right is the physical. So you can actually put those, there's a rotation stage to actually rotate and make sure that the appearance is true to the physical. We also have some of our other technology being utilized for that color calibration between the 2 displays, such as our i1 Display Pro for the display, and an i1 Pro 2 for ambient, and the lighting in our SPL-QC booth. So to speak a little bit more about the appearance exchange format. So the AXF file is the digital twin of a physical material, comprising full appearance measurement information plus metadata. So the metadata aspect of this is really important, because if you are sharing this file, they may not have necessarily a need for the visualization, but they may find that the metadata that is created is useful. So this is information about the material, such as formulation, who created it, the date, things like that, that are also helpful in communicating information about a material. So some of you may be familiar with our color exchange format. This is basically an evolution of that to contain more information about the material, like we talked about, going beyond color. So our AXF material models, we're going to be talking more about the car paints today, but I did want to at least present our other representation for other materials. And you'll notice on the bottom here, this one is a rendering that was done in Red, which is another automotive rendering software primarily used for the automotive industry. So for all of our materials, what we're doing differently is that most acquisition or measurement of a material is done from one angle, and it's done from one lighting condition. Well, what we're doing is a spatially varying version of that, which allows us to actually get much more information about the material so that we can measure these in a way that you could bring it into any lighting condition and get the expected results versus a single RGB camera and different and potentially different light sources that only give you one set of information. For our car paint model, we're doing the exact same thing, but adding another layer to this, which is for things like the color travel and the flake inside of a car paint. So there is no other device out there that is able to capture this type of information about a material. So there has been a lot of work on our end to work on car paint specifically because this was an issue for many of our customers. In fact, this is the industry that we primarily introduced this technology to was the automotive industry. And this just shows some of the other information. And something important here is not only can we measure and represent the texture, if there's any type of texture to the material, but we can also measure things like orange peel in the clear coat. So whether that's a desired or undesired effect of the material, it is something that we measure. And then in our last release of PANTORA, we also introduced, based on the Dassault Systems PBR shading model, which is a physically based rendering shading model, their energy preserving GGX model, which it helps in rendering times, but also understands how energy is gained or lost depending on the type of material. So that was just introduced in our latest release, which was actually the end of last year, and our new one is coming out very soon. Here's an example of how different lighting conditions, how the material is able to adapt to different lighting conditions. On the left, we have an outdoor situation, and then on the right is an indoor office conference room situation. So you can see how the different, how they look differently, but both are accurate and dependent on their lighting. And then here's just a quick video of showing the flake representation and how we can accurately measure and capture that as well. All right. So just a case study here. One of our customers, VW, is utilizing our technology. There are not many customers we're allowed to talk about, so we're very pleased that Volkswagen and Audi have allowed us to show what they're doing in Germany with our products. They have 2 of our TAC 7 scanners and 1 of our virtual light booths. And here are some renderings that they shared with us. So this one done in red of an interior. We have some different seating close up of those. So all these materials were scanned with our TAC 7 scanner. And then here's a slide showing how Audi is using AXF as the base layer in everything that they do, and how they've completely changed to where they're only using our AXF file format for all of their visualization, whether that's internally or their configurators that they use online, and that they're using different rendering engines and are getting the same results across all those rendering engines. So they've been completely confident with this workflow, and we're really pleased that they were able to share this. And then lastly, we do have a free AXF viewer available online. If you go to xrite.com/AXF, we have some sample AXFs as well as our free viewer. And I encourage you to download that if you want to take a closer look. And please reach out to us if you're interested more in the technology. Thank you so much. I hope that was helpful. And we are doing this in a much quicker format, just a 15-minute to 20-minute presentation. So we hope that if you have more questions, that you'll reach out. Thanks so much.
Thanks, Thomas. If you have questions that you haven't submitted yet, please feel free to do so in the control panel right now. While we wait for some questions to come in, I'm going to pop up one more poll here. Looks like we have about 60% of the people answering the poll right now. So I don't know.
Yeah,
Thomas,
do you want me to answer a couple of questions? Yeah.
Yeah, if you want to. One question is, what rendering engines currently support the AXF format?
Excellent question. So I will go ahead. We have a number of them now. I don't know if you can still see my screen.
Nope, let me go ahead and close this.
All right, so, oh, there it was. So here are the softwares that now support our AXF. So in the automotive industry, the big ones are going to be Autodesk Red, as well as Dassault Systems DeltaGen. Although we have customers using V-Ray for Maya 3ds Max, but our integration with these rendering products is become very widespread. But one of the worlds or areas where the automotive industry is really working hard to create content is with the gaming engines such as Unreal Engine and Unity. And AXF is now built into both of those softwares. And we're really excited with the work that we've seen from our customers so far and the work they're doing. We did a partnered presentation at SIGGRAPH a couple of years ago with Unreal Engine and Porsche, where they did a whole piece utilizing our AXF materials, and it turned out awesome. And you can look that up actually online if you'd like. But yeah, our integration has expanded a great deal.
Great.
Oh, it looks like one other question about the editing features. So with the car paint, at this point, what you can edit is we have an implementation where you can change color, but we are adding more features to this coming up in September. We're going to have a new release of our PANTORA software for color replacement as well as colored clear coat. So there will be far more editing features. Right now, it's pretty locked down because of the format, but we will be adding a number of editing features. And with that, with that release, we'll be doing another webinar about those features, and please do come back, and we'll be showing more of that in the future. So I think that's it for questions. Anything else? I think we're getting close to that time.
Yeah, I think so. Just as a reminder, you will all receive an email with a link to the recording of this webinar today. And as Thomas said, if you have any questions, please reach out. And for those of you who did answer that you'd like to talk personally, we will be following up with you soon. Thanks, everyone. Have a great day.
Thank you so much. Have a good day, everyone.